Now, this is a perfect example of how we get air into the building and how we get air out of the building. The makeup air unit, which is this blue line, this blue word, this blue arrow, this should be dedicated to the clean room or to the compounding areas specifically. I have a current client and I do a lot of HVAC forensics work, and one of my current clients, originally when the engineer and the architect, they drew the building 5, 6, 7 years ago, they put one really large makeup air unit to supply the retail area, the break rooms, the office spaces, and the clean room and the non-sterile areas with a bunch of VAV valves. And I don't expect you to know what a VAV valve is, but really that's a zone control mechanism, and it's a mess. It's just an incredible, unequivocal mess. So your best practice in the HVAC world, in the clean room world, is that your supply unit is dedicated specifically to those controlled or critical environments known as a clean room, because this makeup air unit needs to hit those temperature and humidity requirements that are actually defined for us in USP 797. We know that is temperature below 20 C, which we know is 68 F, and a relative humidity below 60% relative humidity. So the rest of the facility, again, the retail, the break areas, the offices, or whatever surrounding dispensing areas, patient areas, those can be at controlled room temperature. So we don't need to put expensively controlled air into those other areas, because that's kind of a deal breaker with the wallet. So we want to make sure that if we're designing or retrofitting or remodeling into an existing facility, that we tell our architects and our engineers and our HVAC contractors, we want a dedicated makeup air unit specifically for those controlled environments. That is your best practice. Now let's go to the exhaust blower. This red line, the only way to create negative pressure to quote unquote externally vent is with an exhaust blower. Now there are manufacturers of supply units that say, well, we also have a powered exhaust on our units. Well, it really is a 1-to-1 ratio, which means that they're going to supply 500 CFM and the powered exhaust is going to exhaust 500 CFM. That 1-to-1 ratio does not work for negative pressure. Typically, negative pressure is about 10 to 20%, depending on the size of the space, more than what's being supplied. So let's say that this number is 500 CFM being supplied to the critical environment or controlled environment. This number would be more like 600 CFM. So I would tell you that do not use the powered exhaust on the makeup air unit to use a dedicated exhaust system, right? Now, the other important thing is how do you land that magical number of 0.01 to 0.03? Really great question. It's called a variable frequency drive. Now, that is a control box that you actually don't see here. It's under the roof. It's going to be in your electrical room or your IT room. If you were to, this is called a direct drive, but let's say that this was an old school belt drive exhaust blower. VFDs don't play well with those belt drive blowers. And so if you want to start adjusting pressures on a belt drive blower, somebody has to actually physically get up on the roof and start messing around with the belts and the pulleys to try and make adjustments real time. That is ineffective, inefficient, and there's no call for that. So the VFD panel, and I tell this to architects, it's on all the drawings, that the VFD panel is essentially our speed control mechanism to be able to adjust this exhaust blower so that we can land this magic number called 0.01 to 0.03. So that is a very important key.